Good morning, students. My name is J. Venkat Suresh, Assistant Professor, Gokaraju Rangaraju Institute of Engineering and Technology College, GRIT College. Today, I want to discuss about a topic in unit number 1. Okay, again, the subtopic is construction of parabola by eccentricity method. So here, just before observing the actual construction part, we'll observe the solution. We'll observe the question. What is the given question related to the parabola construction by eccentricity method? So let us say this is the given problem. To construct a parabola when the distance of the focus from the directrix is 50 mm. So this is the given information. So as we are using focus and directrix, this method is also called as focus directrix method as well as eccentricity method, and sometimes this method is also called as general method. Okay, now as per the given data, we'll observe the steps in the animation form. Okay, we'll observe the first step in the solution. Coming to the solution part, let us say this is the directrix line. Let us say this is the line, directrix line AB. After drawing directrix line, I am going for drawing the axis CD. Okay, just observe the animation part. We are having the next step. Okay, this particular line is our axis. CD is the axis. Now we'll move further. Next step in the solution part. Now I am marking the focus. I am marking the focus at a given distance on the axis. So focus is marked at a distance of 50 mm, at a distance of 50 mm from the directrix. Okay, after marking focus, now I want to mark vertex. So marking of vertex is done exactly at the midpoint of this CF. Okay, midpoint of this focal length. So if you observe the vertex location now, that is located at exactly center of the VF. Now I want to observe the eccentricity value, because for parabola eccentricity is equal to 1. Okay, so whereas for ellipse eccentricity is less than 1, for hyperbola eccentricity is greater than 1, only for parabola eccentricity is equal to 1. Okay, so now I want to identify few points. I want to identify few points after vertex V. Okay, let us say I am standing at this point. In this way, I am observing some few points after vertex. Maybe equal intervals or may not be equal intervals. Okay, some randomly I am selecting some points on this line. Let us observe those points now in the animation part. So I am calling these points as 1, 2, 3, and 4. Now I am drawing some vertical lines through these selected points. Okay, these are the vertical lines drawn through selected points 1, 2, 3, and 4. Now I am moving further. I am moving further in the solution part. I want to draw an arc. Okay, with a FS center and radius equal to C1. So I want to draw an arc. I want to draw an arc with a FS center and radius equal to C1. Okay. So if you observe the next part with FS center and radius equal to C1, I'm drawing an arc on above the axis and below the axis. So these are the arcs above the axis as well as below the axis with FS center and radius equal to C1. I'm having an arc here as well as one more arc here on the first vertical line. Let us say this is our first vertical line at the selected at a chosen point 1. Now I am repeating this procedure. Only the change is only the difference here is instead of C1 I am selecting now the radius equal to C2, but center is F only by considering F for every position of for every part of drawing the arc. Okay, only F as center and radius is changing from C1, again after that C2, again after that C3, and again after that C4. I'm drawing arcs on the second line. After that I'm drawing arcs on third line. Finally I'm drawing arcs on fourth line. Let us observe the next part of the solution in the animation. So with FS center, I'm having arcs on second line, again on the third line, again on the fourth line. Now, if you observe the smooth curve from all the arcs from P1, let us say these are the points P1 prime, P2 prime, P3 prime, P4 prime, above the axis. These are above the axis, and some more points P1, P2, P3, P4 are below the axis. Okay, if you join all these points and if you draw a smooth curve passing through the vertex, is nothing but our required parabola by using this method, eccentricity method. So this is the final solution. In this way, construction of parabola by using eccentricity method is observed. Okay, students, thank you one and all for listening my